Differential scanning calorimetry, commonly known as DSC, is a thermoanalytical technique for polymeric and non-metallic materials. Most commonly used for detecting glass transition temperature and other thermal properties of these materials. This technique tracks the amount of energy required to increase the temperature of a material by a certain amount. By making accurate measurements of heat capacity and temperature, differential scanning calorimetry can detect changes in material properties at exact temperatures, revealing important transition ranges and deterioration points. To perform DSC testing, a small amount of material is heated at a predetermined rate. The energy required to heat the sample is compared to an inert reference material at the same temperature. If the sample under test requires more energy compared to the reference, it is indicated as an endotherm. The peak of an endotherm indicated melting temperature. When less energy is required to heat the sample as compared to the inert reference, an exothermic peak is observed. This may indicate a chemical reaction such as curing. To perform the experiments, first we need to place our sample. So for that, first open the lid of the DSC. So there are two namings, reference and specimen. So you can see these two pans, one is for reference and the other one is for the specimen to keep. When keeping the specimen should touch the bottom of the pan so that the efficient heat flow can be ensured. The specimen size could be from 5 to 10 milligram, not more than that, not less than that. After you place the sample in the pan, then again place back the pan in the DSC and close it with the lid. There are 3 lids, close with all 3 type of lids. So enter a name first. So I'll enter heating for melting. So that's what my experiment is. So I'll enter heating for melting. In order to give the setting parameters, so here we have the sample name. So we can change it. I will send in 7. Okay. And this is the pan type. So different pan types are there. This is T0 aluminium. And the sample size. So I put like 7042. Comments heating for melting temperature because I want to know the melting temperature. And this is the data file name which is going to be saved. So previous file it was N6, so now I am going to change it to N7. And then in the procedure, this is custom, okay, heating for melting, and the RAM temperature is 300. So if I go to editor, I can edit, right? I can edit. If I want to go for 200, then I can do that. If you don't want them, you just can remove it by clicking the cross sign which is in the corner. If you want to bring the data back from that side, then you can do it as well. You just go to that box and click and drag. It will appear on the editing screen. Equilibrate at 40 degrees Celsius. So that's this temperature. So when it comes to 40, the test would be terminated by itself. And here is the heat flow, right? And power 0 watt. So once we start the test, it will keep on increasing. This is the temperature, this is the heater temperature. And sample purge flow, this is the flow of the nitrogen gas. Usually we keep it at 50 milliliter per minute. This is how we open the nitrogen supply. And here you can see the sample purge flow 50 ml per minute. We can set it at knots, right? So in knots we can set the flow rate of the nitrogen, and this is a sample, so whether it's nitrogen or helium, and here is the operator's name, right? So once I'm done with everything, I'll go for run. Reset all runs and then go for run. Once the run is started, we can see the graph is started being drawn. In case if you want to change the parameters while the run is on progress, we'll go to procedure and then we'll go to modify. Right click and then modify running method. And if you click the modify bot, then we can edit. Say for example, if you want to change the 200 degree Celsius into 220, we can do that because it's now in the editable form. Even the rate we can change. Any other parameters we can change. Now I don't want to change, just showing for it. From the table you can see all these parameters which I keep on changing: the heat flow, the temperature, the time, expected time. So these data can be seen. So these are certain buttons to start the run, then to stop the run, in case if you want to reject the run, or to hold the run, and if you want to resume the hold run. Full size plot view. So in the graph, if you want to get the full size, we can click this and we can see the other modes of view also. These buttons are available. So as I mentioned in the introduction, you can see there's a deep steep fall in the graph here. So this is expected to be the melting point of this particular substance. So I gave 240 as the maximum limit. By around 220, this substance melted. And then when it reaches the maximum temperature I specified, that is 240 degrees Celsius, it will return back because the temperature will start to decrease. So the graph will be back to 40 degrees Celsius. Until it reaches the equilibrate rate at 40 degrees Celsius, it will keep on flow. So the heating time would be around 20 to 30 minutes for this temperature range with this heating rate. We can say if it is 240 degrees Celsius and if it is 10 degrees Celsius per minute, it will take 24 minutes to heat up. But in case of cooling, it will take a longer time. Because I didn't specify any cooling rate, I don't need it. In case if you want, we can specify that as well. There you can see it almost reached 60 degrees Celsius. Once the test is completed, just go to stop and press stop. In some cases, this test will automatically be terminated if the heat flow reaches the minimum limit. To open your already saved file, go there, go to file, open DSC, and look for my name. Okay, I got it. So this is the last sample. I put OK, so I will get the graph, right? And say for example, if you want to mark a point, this point, okay, right click, mark. You can move it also, and if you don't want, you can again right click, delete label, okay. And after you're done, if you want to save this, right click, save analysis, analysis only, analysis and data. Usually we go for analysis and data, because analysis only means the software, so the software can only be read in this particular PC where the software is installed. So this data we can't take out and run in our own personal computers. So that's why we go for analysis and data. So these data are Excel file also will be exported. So from the Excel file, if you want to draw a graph maybe in our personal computer, you can draw it. In order to export this data and get it in the Excel file, go to File, Export Data File, File and Plot Signals. Okay, click this, Spreadsheet text file, Unicode, and go to Finish and save it in the form of txt, so that it will save in the notepad form. Name and everything is fine. I'll save it. Already exist. No, okay. Save. To check whether it's saved, I will go to notepad, refresh, C10. We have C10 here. Just open. We have all the test data here, and when we come down, the value is also here. Alright. So once the test is over, take out the sample as like you placed it. Open both the lids and take out the pan, and then remove the sample from the pan. And once you take out the sample, you stop the nitrogen flow. So there we can see the purge flow is keep on reducing. Okay, and eventually will come to a stop at 0 milliliter per minute.